the title, obviously, Aha Moments in Packet Analysis. What are we talking about here? Well, before I get into that, first let me tell you just a little bit about me. If we haven't met yet, my name's Chris Greer. I work for a company called Packet Pioneer. I'm a blogger, YouTuber, instructor. So when I'm not actually analyzing trace files for people, then what I like to do is help them learn how to do trace file analysis, packet capture analysis, and just get better, get more comfortable with looking at trace files. If you haven't gone by my YouTube channel, I invite you to do so, youtube.com/packetpioneer. I was just talking to one of my subscribers here, so that's great. He's in class now. But basically what I like to do out there is just to do real fast snapshots of how to analyze packets. So 5 to 7 minutes of how to examine a window issue, how to examine a slowness issue, where to start with trace file analysis. So go ahead and go by there and check it out if you would like to. Okay, so what's this session about? Well, basically, when has this happened to you while analyzing trace files? Right? And if you don't want to share a story about, whoa, man, the light bulb went on and I really understood something, then what have you learned here at SharkFest? Right? We're on day 3, so you guys have been sitting in sessions for the past couple of days. Hopefully you've learned something. So what was it? And share it, because that's how we can all get better. Now, nobody starts off as an expert, nobody, right? No matter how comfortable we are with trace file analysis, no matter how good we may be at getting down to that one packet that shows us root cause, nobody starts that way, right? It's a growth thing. It's a fluency thing. A lot of times in my classes, I'll compare trace file analysis to learning a language. Most of us in this room are bilingual. We've had to learn a second language, and we know that that process isn't always easy, right? When you first start, it can be overwhelming. Maybe like the same way we feel when we look at a packet trace. At first, it can be overwhelming. But as we get more and more fluency with it, some of that fear can disappear, and we start to actually make sense of what's being said. I know for me, I absolutely went through that process when I moved to Latin America, and I went into a room like this and everyone's speaking Spanish. At first, it's all static, right? But over time, my brain starts to pick out one word, and then the next word, and then the next word, and then before I knew it, more made sense than did not make sense. And in time, I've gotten more comfortable. I hate using the word fluent, because that means that you've really mastered it. But I think as with packet analysis, with a language, you never stop learning. You're always going to practice. Same thing, guys, with trace files, with packet analysis, things that we've learned even at this conference. We just need to get as much practice as we can, and then we can get that fluency. Packet analysis is not a cooking show. You ever see those cooking shows on TV where they just have all these bowls that are pre-prepared and pre-measured, and they put it all in the middle bowl, they stir it up, they put it in an oven, and then ding, it's done, and they break out the whatever finished product is? A lot of times the trace files that you see here at SharkFest are like that cooking show. Sometimes the instructors, we joke about that. We'll put a trace file up there and we're like, see, don't you see the problem? And you're going, no, I don't see the problem. Well, what you didn't see about that person that captured that trace file is the hours that they spent slamming their head against their monitor wondering what this thing is, or filtering it, or finding that one conversation. These are all cooking show, nicely prepared, perfectly filtered examples just for you, right? So you didn't see the pain that it took to get to that point, right? So today in this session, we're going to talk about some of that pain. We're going to talk about some things, personally, I have learned, and some things I'd like to hear about what you have learned along the way that's really helped to make packet analysis an easier thing for you. I'm going to be showing you some example trace files of what I'll call almost like plateau breakthroughs for me in my experience. These are trace files that really help me understand a certain point better. And I want to share that with you because maybe you've seen a similar thing out there, and maybe you can look at the trace file that I'm going to show you, and because you've seen it before, you can go, oh, it's right there, no big deal, right? But if you've never seen this type of thing before, maybe this will help you get through a similar growth point. Now, okay, so I'm going to go first. At the bottom, no mean comments, right? We're going to be talking about some things that are pretty basic, but something's only basic if you've already learned it, right? That's why if I say share an advanced topic that you've learned, well, advanced is in the eye of the beholder, right? If you've already learned something and you've mastered it, that's no longer advanced, but maybe to someone that's never seen it before, like, whoa, that's really deep, right? So when you're sharing your aha moment, try to fight. If you hear someone else sharing their aha moment, you can't think, oh, well, of course subnetting, right? No, this is an aha moment for them. So, and these were all aha moments for me. Now, some of these, the ones I'm going to show you, they happened a while ago. I've definitely learned since then, but these were definitely breakthrough points in my career of packet analysis, okay? All right, and again, I'd like you to think about some examples that you would share with the group. Now, one of my first aha moments that I reached when I started doing packet analysis was packets lie. At first, everyone's going to tell you, packets never lie, packets never lie. Maybe you said it, packets don't lie. They don't when, right? Packets never lie. That it's a data source that comes from a very true place on the wire. However, there's some things that can mislead us. For example, not everything the analyzer shows you is the absolute truth of what actually happened. There is a gap, possibly, between what Wireshark is showing you and what actually happened on the wire. For example, the first one, capture drops. What if the analyzer simply didn't keep up with what was happening on the wire? Right there, simple point. Right, I see in my analyzer 9,000 packets, but actually on the wire what happened was 10,000. So I see a bunch of previous packets not displayed. After that, I don't see a bunch of retransmissions and dupacks and things. If you just go by on a packet trace and you see a previous packet not captured, and you don't see any ugly black lines after that, chances are it just simply didn't capture it. Or whatever it was that we used to capture that event missed that one packet. Now, what can cause that? Well, all kind of things. Maybe we're trying to capture a burst of traffic. Maybe the capture method that we're using simply was over-provisioned at that microsecond of time. I'm going to show you an example of that in just a slide, but another thing, laptop capture is really limited. That was an aha moment for me. What do I mean by that? Taking your laptop, plugging it into an interface, and hitting capture. Does any of you know what the absolute truth capture limit is on your laptop? At what point does your interface that you're using on your laptop that you use to capture, if that's how you capture, at what point does it start to capture untruth? What is that threshold? My question is, what is the absolute point when that begins to happen? You're right. He said, well, it depends on your write speed. It depends on a lot of factors. My question is, if we're using an analysis method to capture traffic, we better darn know when I can use a laptop and when I should start thinking about another capture method. Now, that's a session, actually, if you go back a few SharkFests, I think it's now been 2013, 2014. Yeah, back in Berkeley. I did a session on that exact topic, laptop capture. I brought in a packet generator. We slammed 1 gig, it was only 1 gig, into a Gigamon, and then we copied that traffic out another 23 ports, and I invited the attendees to come up and snap in and capture. See how much of that 1 gig that you can actually collect. The results were shocking, to say the least. All right, so, and we're talking 1 gig, people. So just because you have a laptop and the interface says 1 gig, does that mean I can capture at 1 gigabit per second? Here's what's interesting. Everyone says no. That's correct, Chris. I cannot capture at 1 gig per second. 900 megabits per second? 800? 700? 600? When does your eyebrow start to go, at what level of traffic? That's what we want to know. That's a number we should know. Now for me, just to give you a little bit of detail around packet capture is really limited. A lot of times I have a packet generator that I can use to just slam 1 gig across a wire, and I like to test just at what point, especially if I get a new laptop or I'm just doing some benchmarking. It's one thing to capture every packet. Take, for example, my MacBook Pro. I've found that I can capture every packet if I send a 1 gig packet stream across its bow and I hit start capture. Usually I do a 1 gig packet stream, about 100,000 packets. It's a microburst, boom. But I want to capture everything, right? If it was there, I wanted to see it, especially when I hit go and start capture. I've found that up to about around in the 400 megabits per second range, I can capture 100,000 packets. Okay, 400 megabits per second. That means I got to go from 1 gig down to 400 megabits per second before I can capture all the traffic. That's just for this guy right now in time. Before, my machine before this, I had to get down to about 50 megabits per second before I would see all packets. It was down, I had to go down low. But, that said, what I started to notice, even when I can capture all the packets, even when I did send 100,000 at 1 gig, start capture, or in this case, at whatever level I was transmitting at, start my capture, and I truly collect all of the physical packets that were sent, the next problem began, and that is timing. In Wireshark, I would see a packet with a time signature, a time stamp, and it would show me the delta time between that packet and the one previous to it. And then I would have a ton of packets that came after that with 0 delta. What does that mean? I captured the packet, but the NIC couldn't keep up with the accurate packet timing. So it's almost like it grabbed all the traffic off the wire, said, all this came in at this timestamp. There you go. Okay, now let's go with the next. It's just doing its best timestamp. Okay, grab all this traffic, timestamp. So you would see these large deltas up to several hundred milliseconds, and then just a whole stream of zeros. And then you see 300 milliseconds, and then a whole stream of zeros. So I was capturing 100,000 packets, but the timing was absolute junk. So, turn down the volume. Go from 400, go down to 300, go down to 200, go to 100, go down to 50. Guys, about 20 to 25 megabits per second on this device right up here that I'm using is my threshold for how well I can accurately not just capture traffic, but timestamp it properly. I know that, I've tried, I've shot it, I've seen what it can do. But guys, 20 to 25 megabits per second? Are you serious? How likely is it that I'm going to see a burst of 20 to 25 megabits per second? Pretty likely, right? So here's my question to you. You don't have to answer it now, but I want you to be thinking about it. What's your threshold? What's your level? Whatever capture device you are using, at what point does it start to lie to you? We all know it's going to lie at some point, but what is that point? Okay, so if you ever have the opportunity, this is actually a session we might resurrect next year, doing just a benchmark shootout. Bring up your device and let's see at what point does it start to lie to you. Okay, if that sounds interesting, come up and let me know, because we want to get some feedback there. So, all right, so this was, for me, a learning growth point, where I was like, oh, wow, okay. I can't just install Wireshark on a laptop and go and hit capture and just hope it all goes well. At some point, I got to use some heavier stuff. I got to use some hardware to do some captures. All right. Now, I don't have any alignment or relationship with any hardware companies that I'll recommend to you. Right. I don't get any kickbacks or commissions. But out there, that's why the vendors were there. And there is a certain point when you actually do want to get some proper hardware. Again, on packet slide, down at the bottom, really, really big packets. You've seen those in your trace files. If we install Wireshark on a server or system and then hit capture, that's another area where we can get a lot of untruth, right? We can see 64,000 byte packets. For me, I've had people send trace files and they say, Chris, what's going on here? I mean, wow, this is a lot bigger than it should be, and my MTUs are low, but why do I see a 64,000 byte packet? And they just don't realize, again, where are we capturing from? What's our point of capture? Is that truth of what really happened on the wire? Well, in this case, truth is in the eye of the beholder. Maybe it's what the server saw at that point of the stack where we captured, yeah. But once it hit the wire, what happened to that 64,000 byte packet? Got chopped up and it became many more sitting on the wire, right? So for me, back to our point here, a growth point, packets lie. It's just figuring out exactly when and how can I 100% trust what I see on the screen. Okay? This is an example for you. I just wanted to talk about it as well. At what point I did a test, I was working with a vendor that gave me a lot of different analyzers for doing traffic generation and traffic capture. So at that point, I had a lab with a lot of hardware in it and stuff to goof around with. So I went ahead and set this up, and I just wanted to show you some of the statistics that I got. So what I did is I did a gig file transfer from one machine to another, all right? So the machine on the right was the traffic source. Machine on the left was the traffic capture point. Both of them are purpose-built analyzers for traffic gen and traffic receive. So I was pretty solid that they could keep up with a gig line rate. They were also snapped into exactly the same, like, adjacent ports on that switch, so I didn't have a lot of layer 2 processing that happened. It was basically hardware-based forwarding on the switch there. So I was able to, if I sent 100,000 packets gig line rate to my link partner over there, it was able to capture 1 gig line rate, 100,000 packets, with exactly the right amount of deltas between those packets. So when I see something like that, I'm pretty happy with it being able to keep up with the traffic stream. So there's a lot of span versus tap, and man, you forget spanning. Spanning's horrible. You should go to taps, especially the tap vendors are going to tell you that, right? My question was, is that true? At what point should I really think about a tap? Come on, let's add some, for me, growth point, right? Let's add some truth to this with some actual testing. So what I did is I had hardware-based analyzer, and I had 2 more of them. So I went ahead and tapped that connection, and the ingress port here for the source, I spanned that over to the next port over on the switch and put another analyzer there. So I had 1 data stream, line rate, gig, 100,000 packets, and 3 ways to capture it. Now, at first you might think, oh, they all saw the same thing. You're all going, no, they didn't. But again, at what volume level did they begin to see some difference, and how bad was it? All right, so we turned up the volume all the way. I went ahead and sent my 1 gig, 100,000 packets. Now, on the tap, it captured everything, and the timing was accurate. Okay, great. The span, though, exact same data stream, with that switch doing absolutely nothing. I had now this has been a couple years, but the point was interesting. I lost about 13,000 packets of that 100,000 packet data stream. Now, I haven't done it within the last year, but I realized, yes, at that time, the span, it simply couldn't keep up with that burst of data. So I captured 87,000 packets. So that analyzer, while it was able to capture everything that what was sent to it, there's a lot that wasn't sent. It simply never made it out the span port. Now, another interesting thing that happened was on the span. Now, these guys, right before they did the data transfer, they do a TCP handshake, right? Which is nice, because then I have a way to measure my round trip. Now, the SYN goes out, capture, and it came back, and the round trip time on that SYN was actually faster on the span. The round trip time was less on the span than it was on the tap. What does that tell me? SYN goes out, SYNAC comes back. The switch first sent a copy to the span, then it sent a copy to the source. Whoops. It was slower. This guy captured it slower. Now, I mean, you're talking about a 1 meter cable, so it's not like it was like propagation delay or some other type of network delay. I mean, this was feet of cable here. This shouldn't be that much. And it was enough microseconds for me to not be happy, right? So again, the span dropped. What I'm not saying right here is that all spans are bad. I'm not saying that. That's what tap vendors want me to say, and write blog articles about it and shoot videos and, yeah, spans are bad, buy taps, woohoo, right? I'm not saying that, but there is a traffic point at which you want to start thinking, can my span really keep up with this? As soon as my customers say, hey, I caught this off a 10 gig span, did ya? Okay, right here, back of my mind, I'm thinking, all right, the timing could be true. Depends on how much was captured, right? So there's a lot of dependencies here. Okay, so something I listen for now because of doing this testing. If my customer takes a laptop on a span and they're capturing a good amount of traffic, right there, I know I got to question my trace file. I got to make sure that if I do see missing packets, if I see things were dropped, it's probably true. Now, does that mean that the trace file is completely worthless? Does it mean that I'm just dealing with false data that I just have to throw in the garbage? No, not in all cases. However, it is true that a lot of times when it comes to trace file analysis, sometimes it does come down to one packet, right, guys? Sometimes that smoking gun is there, and you can find it in one packet. Well, I just hope that we didn't miss that one. Okay. All right, so takeaway point, your stuff's dropping packets at some point unless you are doing hardware-based capture from literally tap to outputs into a hardware capture device, and that's doing like a purpose-built thing where it is capturing at line rate. That's why those devices cost so much. That's why think about a laptop. I didn't pay for a hardware-based packet capture device. I paid to do email, web browsing, and a handful of other things, and show you guys a presentation, right? That's why these things are $2,000. if it's a purpose-built line rate capture card, that's why we pay for it, to make sure that it's telling us the truth. Okay, so your stuff is dropping packets, but at what point? That's what I want you guys to, if you ever have the opportunity to find out, and the results might surprise you. Another growth point for me, not all TCP stacks are the same. They have a lot of different behaviors. Okay, so for me, that was absolutely a growth point. As soon as you think that you've got it figured out, as soon as you think, oh, man, I know exactly how this is working. Okay, that window, this congestion window, like, okay, slow starts here. Okay, good, got this all set up. Now I got it. Now you can be an expert at that. It either changes with an update, or you go to a different system and that behavior goes out the window. Now it's doing something completely different. Why? A lot of different algorithms out there, a lot of different behaviors of TCP. So for me, that was a growth point as well. Now, let's actually show you some trace files, because I'd like to do more than show you a PowerPoint, which is kind of boring. Okay, next growth point for me, experts. So most analyzers have the little expert feature, and you hit expert and bam, they show you all kinds of great stuff about the analyzer, right? Those experts can help, but I'm seeing a lot of smiles out there because I think you guys have learned this too. They don't exactly show you exactly what you're looking at. Why? Because no expert system can show you every single problem that can happen in every scenario, right? That's why we have brains and we've had to develop the art of packet analysis. Now, one trace file I like to show this with, this is a trace I got from a buddy of mine, and I named it Really Slow Web Application. Let's see if you can catch some things. Gonna take off bytes in flight. All right. Symptom, simply, he opened up a web-based application, he was interacting with this application, he went to a new tab, or within the app, he opened up this tab, and the data was there, it did populate, but he looked at a spinny wheel. He looked at, the spinny wheel of slowness. He looked at that for over a minute. In fact, it was pretty long. So he sent this to me and he said, hey, Chris, I guess, keep alives are killing my network. Because that's what the black lines say, right? So his eye went straight to the black lines with red letters. Okay, those are eye drawing, right? I mean, that's where your eye goes, right? That must be an ugly thing. But let's take a look at this. Let's actually see what was happening. So to step us through this, excuse me. Okay, so I got a simple handshake. I've got a simple, this is actually an HTTP GET. If I pull over, there we go. Pretty simple HTTP GET. And I chopped it. That's why we don't see a lot of the HTTP information, but that doesn't matter. We're going to go SYN, SYNAC, ACK. Now the client. Now, before we get to what was actually going on here, let's take a look at our handshake. So our network round trip time. If you were in my first session a couple days ago, so that initial network round trip time, 97 milliseconds, okay, great. Let's put that on the pegboard of possibility, of truth. All right, that looks all right. Here's our SYNAC. So to establish the handshake, 104 milliseconds. Not long after that, a whopping 833 microseconds later, we see the client. It goes and does something. Well, that something spanned a full MSS size. So the MSS on this connection was 1460. We could go up to the handshake and validate that, but we see a big packet go by. Well, there was so much that the client was sending to the server that it just spanned 2 packets. No big deal, it was a 2-packet GET. So full-size packet, then residual. At this point, we're still 104 milliseconds and change into our trace file. Again, our symptom, spinny wheel, right? Well, 106 milliseconds later, we get an ACK back from the server. It's empty. There's no data in this packet. 60 bytes, right? That's missing the FCS header on the end of the Ethernet frame. So in truth, it was 64. But this is just an ACK. If we want to, we can come in just to make sure, just to validate this. If I take a look at my sequence numbers on those first two packets, let's go to HTTP. Sequence number 1, I'm sending 1460, so my next expected is 1461. All right, so we start at 1461. We're sending, where's our TCP segment length is 35, so this is just a small amount, just the residual traffic that didn't all get shoehorned into one packet. And next expected is 1496. Server comes back and acts 1496. My stuff got there. Client stuff got there. Sent 2 packets, got ACK back. Good. Then what on earth happens? Somebody said, now we wait. And you are right. 45 full seconds later, client says, hey, server, we're good, right? You didn't go anywhere? Did you hang up? Did you die? Server comes back 99 milliseconds later. Yeah, I'm here. Right here, man. We're cool. It's good. All right, just checking. 45 full seconds later. You ever been on hold a really long time? Don't you kind of appreciate it when the operator comes back and maybe they don't say anything, but they're like, we're still here, please hold. You're like, at least there's a human on the other end that might be doing something. So again, another 45 seconds later, we send this TCP keep alive. Now that is exactly what TCP is doing on the client side. It has heard nothing back, so I just got to know. So, and in this case, this TCP stack, 45 seconds. I got to know, am I shutting this thing down, server? Am I hanging up the phone? Or, did you go away? Did you move on to somebody else? Just tell me. What's going on? He comes back, yep, I'm still here. All right? We do it again, 45 seconds. We're going to maintain this connection. We're going to keep it alive. Kind of interesting with the keep alive, just so you guys know if you haven't seen this before. Another little interesting growth point. When I check in, check out my sequence number. So I check in, right? I was up to 1496, right? But now I back up to 1495, and you see my TCP segment length? 1. That's part of me just checking. So in a keep alive, all right, I'm up to 1496, but in this keep alive, I'm backing up just 1. And if he acts that 1 byte that I send him, cool, we're good. But I want to make him do something. I want to make him say something. So I'm going to back up I'm going to back up a byte and I'm going to send it. You're going to ACK it. Okay, that's a keep alive. Now I do exactly the same thing with the second keep alive. All right, come down here, 45 seconds. I back up again to 1495. Send that 1 byte, if you will. He acts 1496. He's still there, server on the other side. All right, so up to this point in my trace, the poor client's been waiting now. What's my time column over there on the left? That's running total of time. That's 90 seconds. That's human wait seconds. I asked my buddy, how on earth were you so patient to wait for this application? I sure wouldn't have. That's like go get coffee kind of delay, right? Packet 11. Server comes back with stuff. Great. Packet size 572. This is where I get my HTTP response code. My total amount of delay was 108 seconds. That's how long we were waiting for this application to respond. That's a lot. That's a lot, right? So a lot of things were being claimed about this poor application, and of course my buddy's from the network side of the house, so he was just getting hammered on by the app guys. Your network sucks. I mean, look what Wireshark's telling us. Look at the black lines. That's network. right. Let's all get a growth point. No, that's not network. And just because in this trace file, it's actually one that I like to use in training because it helps people see. Again, we got our black lines and red letters. Things look scary, but let's really interpret what those scary things say. Because around that, right, I mean, TCP is just trying to keep the connection alive, to keep it going. There's nothing wrong with those packets. Now, again, we also learn, TCP retransmits, right? So the client, it sent this request to server. Packet 6 means everything. That's my ACK from the server. I call this a hush packet. That's the server when it responds, but it doesn't have any data in the response. So the server's just saying, great, I got your get, chill out. Shh. I'm doing stuff here. Right? So it's off to lunch or wherever it's gone, or whatever database or whatever is going on the back end. Or it just simply sat on that request for 108 seconds. From this trace file, we don't know. We captured client side. Next step to figure out that 108 seconds, we needed to move server side and see what's going on. And when I see that request come in, then what? And then we could move forward with the analysis. But let me back up. Takeaway point from this trace file. Yes, the scary looking black lines and red letters and alerts that we see, those are helpful. However, we really want to back up and make sure that we understand them. And don't let your eye get too distracted by those things. Because sometimes, I've seen people with this exact trace file, they just get very hung up on those TCP keep alives, and they just don't see what's around it, right? So growth point, right, for me was, make sure that we understand in context what's actually happening here. Any questions on that one? I'm going to move on to another example. Hopefully this is useful to you guys. Yeah? All right, cool. All right, let me show you another one. Now, you guys might think, I've seen that, no big deal. But for me, this was a big growth point. So this was when I learned a bit more about MSS versus MTU, which is always a fun lesson. All right, so symptom, client side. I go try to download a file from a file server that exists in another area. It's slow. I sit and look at nothing for 20 to 25 seconds, and then all of a sudden the file appears and I can open it. All right? That's what the complaint was. Again, slow, delay, right? I still have never been called yet about something that went too fast. Maybe that day will come. All right, so Synact ACK, we got our handshake. Let's do just our quick thing. 86 milliseconds a round trip between these two guys. Great, thank you. We've established connections. So right now, at least we have a TCP connection between these two endpoints. I get a packet from the server, and the client does its little search request thing. Server comes back 93 milliseconds later. I'm pretty happy with that because of the network round trip time. Server comes back, 617 bytes total was the packet length, but Wireshark's telling me TCP previous segment not captured already. All right, client, dupeACK. So I've already gotten up to this ACK number, so I use a dupeACK. We'll look at that in just a second. I don't get a retransmission for 21 seconds. I don't know about you, that is a long time to wait for a retransmission. I thought TCP was better than that. This trace is old, but not that old. Maybe a year or two-ish, maybe. I mean, shouldn't it do a lot better than 21 full seconds? So, all right, that's just a note to self, but maybe, again, does this match the delay that the person was complaining about? Yes. They told me 21-ish seconds before they start to actually see stuff. Okay, so right there, there's something I want to look into. And then as I go forward, okay, we start to see stuff fly around. So all right, we need, client trace is nice, but we need to go server side. We got to figure out what's going on with this 21 milliseconds. So let's open up the other side. All right, so here's our server-side perspective. SYN comes in, immediately SYN-ACK goes back. We have our 86 milliseconds around trip time. We get our search requests come in. Now, according to the server, it's a rock star. It responded in 236 microseconds. Man, it's fast. Boom. Full-size packet. And then this residual one. Full-size packet. So a 1514 and then a 617. When it comes to actual TCP data itself, the segment length, look there, 1460. The next one was 563. So did I see that client side? Yes, I saw this 617 come in, but what happened to this guy? Well, ACK comes in from client. Client says, let's look at its ACK number. ACK number 1. Okay, so that is the same as what we had seen up in the handshake, but let me come down. Oops, I'm zoomed in 1 second. There we go. Let's come down to our options. We have a SAC, right edge, left edge block. We got a SAC block here, and it tells me 1461 to 2024. So this block right here is the client acknowledging that 617. Right? But the gap in sequence number is between that ACK number 1 and 1461. So the client is saying, I got the second one, but there was a gap in sequence numbers between 1 and 1461, exactly that 1460 that you sent. I have a space in sequence number, but I did get that second one. Missed this one, got that one. That's what client says. What does server do? Cool. Retransmit. Now this is a full 1460. All right? Now, how long did it take to get that retransmission or for that thing to send? See, 3 seconds. That's how long it took the server to begin to send. Now, we've seen this in other classes. We've seen this around ourselves. How come I didn't see a fast retransmission? Right? We've seen that whole TCP thing happen. Fast retransmission. Now you'd think, oh, you told me about a packet that was missing? Boom, here you go. Why does it wait 3 full seconds? You need more duplicated acts. We need a triple-double. We haven't seen a triple-double here. Triple-double meaning 3 dupe acts that can trigger a retransmission, a fast retransmission. Here I just got, well, the original act was the sequence number 1, then I get this dupe act, sequence number 1, but I need 1 more of those before I will retransmit. So this actually happened at the worst time it possibly could, because if this was further down in the trace file, I would have had more dupe acts coming in from the client. The client simply didn't have that much to acknowledge. Okay, that's why it doesn't trigger a fast retransmission. So here, it sends its retransmission. Here you go, client. Chill out, man. This will fill in the gap for you. Here's my 1460. Client, 6 seconds later. Client, 12 seconds later. You see our total delay over here? 21. This one finally made it through, but what's the size? Okay, so what happened here is the server tried 1460, right? Sent the 1460, all right, didn't make it. Okay, here's my retransmission, still didn't make it. I'm gonna wait 6 seconds here, retransmission, still didn't make it, all right. So what TCP does, if we look in the How TCP Works fancy books, if I am in doubt about MSS, the stack can, which is a fun word, right? Try, yeah, could. It's not a must, it's a maybe. It can try the lowest when in doubt MSS, which is 536. If I don't know, or I never got that option, or if it was washed or whatever, my when in doubt MSS is 536. Hey, so these big ones aren't working, so let's just try. Let's go to 536. That's my minimum. Let's give this a shot thing. So the server does send that 590, and what happens? 96 milliseconds later, packet 11, client comes back with an ACK. It got there. All right? At that point, for the rest of the life of this trace file, or this guy is an anomaly right now, or we'll get to that. But just to take a look at the packet size that the server used for the life of this connection. So once we were down to that known number, the server's like, hey, it worked, so let's go ahead and get that going. All right, so why did this happen? Let's take a look up at our, I want to show you guys. So for me, okay, well, a couple growth points here in this trace file, but I wanted to show you an aha moment for me. I never got the 590. I got the, okay, so MTU, all this stuff. I'm also going to show you something else that, in the handshakes that ever since this point, I've just kept a much closer eye on MSS sizes, full honesty here. Why did it pick 590 or 536? Never got that until actually broke out the books and read, okay, that's the minimum MTU MSS that it will try as kind of a last-ditch effort. I just never knew that until I actually saw it here. And then I saw it in the book, 536. I just broke out my Stevens TCP Illustrated. It's right there. Boom, it will try 536. Sweet. Okay? Now, why did this happen? If I come up to my SYN, let's take a look at our MSSs. Okay, so maximum segment size. The client said 1460. It said it could receive that. Nothing on the network changed that. 1460 all the way. We should be good with those big packets. Now, server responds, great, cool. I can do this. You can send me 1460s as well. We're good. Let's look at the client side. Okay, SYN goes, MSS. Okay, 1460. This is the client is sending, and I'm capturing client side. Server comes back. 1432. What was it when I sent it on the server side? 1460. The client received it at 1432. What happened? A router reached up and went, nope, somewhere along the way. Now, this only happened in one direction, right? Because the client sends 1460, it arrived at 1460, server responds 1460, but it arrived at 1432. So one way the router was changing it. So what had happened in this case was, in this specific client-side location, they had done a recent router swap or upgrade or something. What was happening in the outbound direction, it was supposed to be switching these SYNs. It was supposed to reach up into these SYN packets and change the MSS. And that's a command that we can do on routers. In the opposite direction, that command was doing its job. It saw the SYN-ACK come back from the server, went up, tweaked it, and then as it arrived at the client got it. But in the opposite direction, the outbound router wasn't doing that. So we just went in, changed that to 1462, because they had some stuff going on in the middle. We had to get some of that header space for extra stuff that's beneath TCP. As soon as we did that, we saw 1432 in each direction, and that 21 seconds of retransmission delay went away. Now again, there's several points. If we had never seen this type of problem before, okay, we're going to keep a much closer eye on those MSS sizes, right? But another thing, yeah, the network can make those adjustments if we tell it to. We can, at routers, we can have it go up and change MSS sizes. Go ahead, sir.
Was that a Microsoft server?
This was.
Because Microsoft has got also black hole detection.
Yeah.
Level, which does exactly the same thing.
Yeah. Now in this case too, what I also wanted to see, And this was a filtered trace. What I didn't like about the way it was captured is that it was filtered and they just did it specifically on the client IP. Because on the server side, there was a lot of clients coming in, or client IPs coming in. So they just did a capture filter on only this client. Now, with that statement on the server side, right, so they're just, this is a trace wrangled capture here, but on the server side, since they're capturing only stuff coming in from this IP, what other information would have been useful? When I'm capturing, if I'm server and I'm only the IP of that client is coming in, that's all I'm capturing. What am I missing that would have been useful in this case? Possibly, if the network, ICMPs. It's possible the network at some point could have been saying, hey, thanks for big packet, can't forward it. And that would tell me where to look. But since I over capture filtered, there is some data missing. So I didn't specifically learn that on this one, but sometimes capture filters are going to get you into trouble, right? How many times has that bitten you? Where you think you know the problem so much that you set a capture filter, turns out the real issue or the symptom that would have led you to the real issue was not in the trace file. Why? We over-filtered. So careful with your capture filters if you can be. I know that's not always the case. Let me see. I want to say yes, but I'd rather be sure. Yep. We have a don't fragment. So, okay, moving on. I've got a couple other ones. But you know what? I'm actually going to, we're going till 11:45, I think? Okay. I'm going to show you one more example, but I actually want to hear from you. So after this, I'm bringing a mic around, and I want you to tell me what were some of your experiences you had where something just went boom, whoa, that's how that works. And don't feel like you have to tell us some super crazy expert level event that ever happened in your life. It could be something simple. In United States, when we did this, one person was like, I'll never forget the day when I finally got subnetting. We giggle because it happened to us too, right? All right, so you're not alone, whatever it is you learned. Here, let me show you this one. This one was... Okay, take a look, take your time. I'm not going to hurry you, it's all right. Okay. Sin. Retransmission. Retransmission. Whoa, you're there. Probably the worst place to ever lose a packet, right? Okay, so symptom, stuff's slow. Stuff's randomly, intermittently slow. Sometimes you do not experience any internet slowness at all. You're going out to whatever service and things are working fine. Sometimes that's not you. This problem was affecting everybody at a client facility. It wasn't always you. It wasn't always not you. Some days you never saw it. Then the next day you came in and nothing seemed to work for 10 seconds or so. And then stuff started working again. Random, intermittent slowness. Isn't that a lot of what we troubleshoot these days? Okay, so we were able to capture, and I'll get to the growth point part about this in just a minute, but I want to build out the story a little bit. So we went ahead and started this capture. SYN goes out. Retransmission, retransmission, SYN-ACK. So right away, just throw it out there. What ideas come to your mind? Max table? Any other ideas? Sorry, say that one again. New connection. Maybe on the server side, it couldn't handle somebody new. Maybe the server's busy. It simply doesn't have any more room for a new connection, and then 10 seconds later, some table cleared and it's got room.
So, to which packet was the SYN ACK? Was it the first, second, or third?
His question, to which packet this SYN ACK, which SYN ACK, or which SYN was being ACKed? Can you tell me? Let me put it this way.
Read the red lines exactly. So,
Oh, okay. Here.
nothing.
Yeah.
Okay.
Okay, first of all, again, question was which SYN is being ACKed? Is it likely that it's the first one? I'm just saying likely. I mean, that would be 9 second between SYN getting there, and I mean, does it hang out in the ether for that long? I heard an instructor say one time, and I totally believe what he said. He said, "There's no red carpet lounge for packets." You know when you go to the airport and you're waiting for your flight, and you can go to the red carpet lounge and you can just hang out? That concept doesn't exist for packets. They don't just go to some place and just hang out for a period of time, just to hang out. I've heard that a lot. Oh, the switch, it sat in the switch for 9 seconds. Did it? That's a pretty awesome red carpet lounge. I want to go to that red carpet lounge. Yeah, man. What do they got? Like Dom Perignon champagne? They're doing something right in there. That doesn't happen. Not for that length of time. All right? I'm talking 9 full seconds. All right? So it's unlikely it was the first one. It's unlikely it was the second one. The reason, when we finally did, okay, here's our SYN. We got our SYN ACK back. Our delta time between SYN ACK is 3 milliseconds. Now, anytime, that's the reason why this is such a great number to put in the back of your head when you're doing your analysis is you should see that number somewhat, I'll use the word consistency, take that with a grain of salt. You'll see that number as you go throughout the trace, as things are exchanged, as data comes, and then you get an ACK. So we got 3 milliseconds. Do you see another 3 milliseconds down a little further? Okay, so there's my network round trip time. I see that 3 again. So that 3 milliseconds is not an unreasonable initial network round trip time. I see it again. So it is most likely that the third packet, great question, the third packet, this third SYN, is the one that actually worked. All right? So then I made a colossal mistake, and I'll admit it. I thought, because, be honest, this has happened to you too, so quit laughing. I thought the outbound firewall must be limiting the number of connections that this user can goof around with. If you were in my first session, I showed you an example of that with resets, where you got 300 connections, and then after that, your connections are being reset. I literally had just done that analysis for somebody else. So I made the colossal mistake of assuming that this was the same thing. I mean, I didn't absolutely come to that conclusion, but it steered me to the wrong thing, right? We all do it. What you've seen before, it's easy to knee-jerk that here you are seeing it again, right? We've done it, we do it. Fight that tendency, especially when it comes to packet analysis. Really, really try to have an open mind each time, because it just might be something else. So I was like, hey guys, let's check out that firewall. Man, that firewall's like not letting you guys like send out those SYNs, and man, this has got to be what it is. Well, in my defense, we went on the firewall and it showed a bunch of outbound packet loss. It was like this, it wasn't a very sophisticated firewall. It just said connection drop, connection drop, connection drop. This counter was going up, and I thought, look, man, it's right there. Well, thankfully, I thought, something's not right here. Let's capture this again, but let's move. So we moved from the client, and we moved just outside that firewall. Okay, because if I was right, we would have seen nothing out there, right? We would not have seen those sins go out. We wouldn't have seen the sins go out. So again, I don't know if you would call it growth point or life lesson. If you're going to make a claim it's that sure, or if you make your money by doing this, if you're going to make that assertive of a conclusion, test it first, right? So we went ahead and went from the client perspective to outside firewall. And I'll color it just for a second, then I'll remove the colors, just so you can see. My sins are always green. Okay, so you can see the top there. All right, now I'll remove the colors just so it makes it easier on you guys. Sin. Synac. Server responded to the first one. Client waits a few seconds, retransmission. Sin, retransmission. Server, packet 4. Yeah. Synac. 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 Client. Sin. Synac. Synac. What the heck is your problem? Was the firewall letting it out? Yeah, so that whole assumption went right out the window. Sins went out, Synacs came back. Now these Synacs weren't making it to the client, right? We just saw 3 sins. Sin, sin, sin. Synac, happiness. Now we see sin, Synac, good. Things are coming back, all right? Retransmission both ways. These guys aren't talking. Now where does your brain go? What the heck happened to that Synac? All of them. Okay? What? So now what do we do? I mean, this is a pretty simple network. You basically had client, switch, firewall router thing. There's really only 2 boxes where it could have gone, so to speak. Either the switch layer 2, this thing was flat. I've already talked about hammering on that poor router firewall, but let's move from outside the firewall to literally just inside the firewall. On that literal connection between firewall and switch. Let's move there. Inside firewall. Let me turn on my colors for just a second. Did the Synacs make it back in through the firewall? I'm inside the firewall now, guys. Sin? Synac? Sure enough, handshake, sin went all the way out, got to the server, came back. I captured it outside the firewall, I captured it inside the firewall. Between the firewall and that client, which was literally one switch, these Synacs are going somewhere. But not all the time. So now what do we do? Look at the switch. We could look at that. But in this case, you're... What's that? Plug the client to the firewall. Why didn't I think about that? ARP table. Okay, here we go. So a lot of times we can be just like TCP nerds, right? TCP is awesome. TCP is awesome. But guess what? Layer 2 still matters. So, layer 2. I'm going to bring this up, guys. And just, because, I mean, I'm guilty of it too. We've all done it. If you're a bull-faced liar, if you say you never have, we jump right over that stuff sometimes, right? We're looking at something, it's like, oh, layer 2, it just works, okay, boom, let's get to the stuff that matters. It's easy to overlook something. But in this case, let's back up. Layer 2, MAC address. It's coming from this device, and it's going to this Sophos firewall. Let's look at the response. From the firewall to somebody else. So it comes in, SYN comes in, SYN-ACK goes, woo. The client's none the wiser. It sent a SYN, but it didn't get the SYN-ACK. Let's see this again. This is SYN from this poor dude. Goes to firewall. SYN-ACK comes back. Woo. In this one, I gotta see, did this one ever get right? Okay. All right. I'm just gonna use my colors just so the ARPs are easier to see. So it's another trace file. Same environment, but this showed it the best, okay? So any server, any given device on this network does an ARP for 10.127. If you're out there, tell me, how many responses does it get? And are the responses all the same? No. I hopefully would get one good response. I got 3, and they're all different. So here's one Cisco device, hey, I'm .7, another Cisco device, whoa, I'm .7, and then this Apple device, I'm .7. Now in this case, depending on which order you received those ARP responses would depend on whether you really worked or not. In this case, I'm ARPing, let's just say .7 was really that Apple device, which in fact it was. These 2 routers, which were doing proxy ARP for the entire subnet, were responding on behalf of all addresses on the subnet interior, on that network. Both those guys were doing proxy ARP. So it didn't matter which IP I ARP for, I got ARP responses from those 2 guys. They thought they were doing me a favor. But then, hopefully, I would hear from the real guy. If I heard from the real guy, the last thing you've heard is what goes in your ARP table. So if I'm ARPing for .7, I get 3 responses, and Apple's the last one, then I'll use that most recent information, and me and .7 will have a great old time talking. But let's just say Apple was fast. What if it was like, yeah, I'm .7? Then one of those 2 other routers then responded if they were a little bit slower. That now becomes the most recent information in my ARP cache, and that's the guy that I'll talk to. So what was happening is that the client would ARP for the gateway. Most times, the true gateway would happen last. Those 2 routers were like, oh, I'm the gateway, I'm the gateway. Then the Sophos would be like, no, I'm your guy. SYN would go out just fine, but on the response, that firewall is always updating its ARP table, it's sending ARP requests, and in many cases, it would hear from one of those Cisco boxes, and it would send the SYN-ACK that way, instead of back to you. So in this case, I'm like, what on earth are those guys doing proxy ARP for? There's not really a good reason. We disabled it, and this was fine. Everything worked fine. The system that that's a whole other conversation, but the system they were using it for didn't need to use proxy ARP. So, growth point, back to life lessons in packet analysis. Lots of them from this one, right? First of all, careful about assumptions, right? That's always, no matter what we're doing, we should be careful about that. Also, capture from multiple perspectives. Get it from the client, get it from different points in the router, even if it's literally one switch hop, one switch segment away from you. That provided the key. All right, so even it's layer 2, I'm not even crossing a router here. From one switch interface, moving the point of capture to the next switch interface is what revealed the problem. All right? And then 3, when you make an assumption, be very careful about running away with it before you can validate it. Be very careful about doing the colossal mistake. I've seen this before. Here it is again. This is the problem. Because I kicked the heck out of that firewall for a while before we moved our capture points. And then it was like, whoa, wait. And then, of course, last one, layer 2 really matters. So don't overlook it. Avoid the it just works thinking. Like, make sure to validate that.
One question.
Yeah.
What made you decide to send the third act, the third SIN, with a smaller length?
This one? Good question. It's not TCP length. You know what? I'm going to dig into that and we'll check it out. But before I do, since I'm running out of time, let me benchmark that, or I can throw that one on the shelf for right now. I want to hear from you guys, because this is supposed to be a forum, but I've done a lot of talking here. What aha moments have you had as you have learned how to do this thing, this art of packet analysis? What issue did you run into? It doesn't have to be long, guys. You can literally say it in 10 seconds. But what issues have you run into where you've gone, whoa, okay, wow, now I get how that protocol works? If you don't have something to share like that, then I want to hear what you've learned at SharkFest. If you haven't learned anything at SharkFest, I'm sorry you've wasted 3 days of your life that you will not get back. It's not my fault. All right? On to you.
Window scaling.
Window scaling.
When I figured out how that worked and what it did, it was a bit of an aha moment. Because I was going, like, how the hell is it still receiving packets? It should be full.
Right. He just said window scaling. You guys remember when you've learned that one? If you haven't learned that one, that's okay. But the first time you realize, especially if you've missed a handshake, how can it be that a client is advertising a 50-byte window and I'm still sending maximum MSS sizes to it? That one, I've gotten a lot of questions. People will send trace files. It's a window problem. Look how small the window is. It's like, oh, we missed a handshake. Thanks for sharing. We've all been there. Anybody else? Go for it.
Baselining, you don't have to memorize every application or every protocol.
Nice. Baselining, you don't have to memorize every single protocol or every single application. Yeah, go for it.
I learned the idea of where's the point of capture, and to use in many situations use tabs.
Okay.
For me, a new experience what I learned here right now, because for most of these capturing what I needed for, I used the laptop until now.
There we go. All right, yeah, it's an important point. So he just said about, capturing, not just in capture location, but sit back and really think about what are we capturing and where. So yeah, that's a good one. So really, I mean, honestly, we're coming up against time, so I'm going to do a mini wrap up. But thank you guys for sharing some of those aha moments. Keep sharing these things, guys. I've talked to a lot of you over the last few days, and In many cases, you are the representative from your company, network, organization that is here at SharkFest. But there's a lot of people that didn't get to come, right? From your organization. So share your aha moments, share what you learned here. But just a couple of instructor level aha moments for you, because you're going to turn around and walk out that door and be a teacher to somebody else, right? And just remember a few points. Not everybody gets the same thing in the same amount of time. Here's a few examples. Subnetting, TCP windows, sequence acknowledgement number analysis. These are all things that took practice for us to get to, right? So be patient. You might have to go home and teach the same person what a window scale does about 10 times. But they're going to get it. So be patient with them as you're sharing your aha moments. Guys, I hope this was a helpful session to you. We do have a few minutes before we do the closing wrap-up thing at 11:45, so we've got about 5 minutes of coffee time. But thank you for coming, and thank you for sharing your aha moments. Thanks.